Okay, welcome back. I'll just give everyone a few seconds to sit down and get comfortable for the next hour. All right, kia ora. The next session is by a bunch of fabulous researchers from a variety of different organizations, and they will be talking about upskilling researchers in machine learning. It's a both interactive, but
Kia ora koutou. There's a few of us here, and we'll talk to you in a second. This BOF is to go over essentially the state of upskilling in machine learning and AI in Aotearoa at the minute. The idea of this BOF is to just try and get a summary of the landscape as it is, who's doing what courses, what do you need to be taught, and things like that. So we've got a survey that will take up a chunk of it to stimulate some conversations. And we'll give you a quick summary of at least what this small fraction of us are doing currently at the minute. So with that said, who are we? I'm Mike Laverick. I'm one of the solution specialists at the University of Auckland, and I'm joined by my lovely colleagues over here. Do you want to shout loudly, or do you want me to?
I'll shout. So, hi everyone, I'm Maxime Rio. I'm working at NSC as a data science engineer and at NIMA as a data scientist.
Hi, I'm Murray. I am a scientific programmer at the University of Otago in the research, teaching and support area, and generally do a lot of training through the carpentries.
Kia ora everyone. My name is Craig Collins. I'm an engagement specialist at the Centre for eResearch. I started back in August part-time, and I've just gone full-time. This is my first full-time week.
He's also finishing up his PhD, so he's super caffeinated. So I'll hand over to Murray for this bit.
Cool. So to get things underway, we've got the traditional icebreaker because it's a BOF. So over on Slido, get into your groups. Surprise, you're already in your groups. So whoever you're sitting next to at your tables, they're all numbered. So get comfortable. There's going to be discussions throughout the session. But the first one is, what does machine learning, deep learning, artificial intelligence mean to you? Because when you enter this sphere, things mean different things depending on when you learnt them. And there's new terms coming up all around the time. So head over to Slido. We'll have about 5 minutes for this activity. Discuss with your neighbours. And as you think of things, enter them in, and we'll end up with a nice word cloud coming up here. You can put in multiple words.
What does machine learning, deep learning, and artificial intelligence mean?
So about 1 more minute, people. For the people coming in, find a table, join the survey. This is about 1 more minute of answers. So new people coming in, join a group, start discussing. So if you fill in on the Slido, there's no right or wrong answer. This is the icebreaker. Then we're going to sort of define what machine learning means to us.
That's the side. Or I can watch it link if you want, it's easier. Oh, you won't have.
Yeah.
Yeah. That's all right. I was like, you just need to type M and then it'll take you to it. It's like, no, that's my browser.
Right, cool.
So,
Over to you.
yeah. Cool. Hello? I think it's working now. Oh, yes. There is a bell. That's awesome. Brill, glad to hear there's so much chat going on and seeing some of these lovely, lovely terms. We've got quite a range of them. I'll go top to bottom because that's how I work. New, exciting, and what's on the other side after the hype. For some reason, AI's come to the forefront in the last year or so. I'm not particularly sure what technology or piece of software has come out in that last year to make us all care about it, ChatGPT. But as someone said here, machine learning itself is essentially fancy stats. Someone's show me the money because anyone who starts working with AI gets scooped up by big tech companies. It does take massive amounts of data, and it can do all sorts of tasks such as land cover classification, and it can train on biological data and basically just speed things up for us. An exciting black box is something that I can empathize with because it can be quite tricky to understand this level of stats. So there's some really good answers there. And one of the things that we're going to do with this BOF is if by the end of this session we get hold of your email, we'll then summarize everything that's covered here, including the survey results, to try and survey this landscape and just basically find a way of plugging people back into what's happening in New Zealand at the minute, and then hopefully we can start going forwards with all the stuff that we start discussing. So what we'll do now is we'll have a quick overview of, yeah, they are the same. We'll give you a quick overview now of what we've done at the Centre for eResearch and at NESI in some of the teaching and learning that we've been doing to try and help upskill researchers in machine learning and in deep learning. But before that, because I'm a bit of an idiot, I will plug in this other laptop and give you the textbook answer, which is not correct entirely, about what we think AI and machine learning and deep learning represent. Maxime recognizes the diagram. A couple of other people might as well. So broadly speaking, artificial intelligence lives as this big giant wrapper around all of this. It's typically, or it used to be used as a term that was a program that could sense, reason, act, adapt like a human would. More recently, the term AI now essentially means machine learning. And so there's a new term which is called artificial general intelligence, which are these AI monsters that act and talk like humans and can solve lots of tasks. And so if you hear AI nowadays, it can be as simple as machine learning, or it can be as complex as a world-ending Skynet robot that can kill us all. Machine learning itself represents algorithms that can improve their own performance when they're exposed to more data. These can be as simple as linear regressions. So if you've ever done a line of best fit, which you probably did at school, if you do that on a computer, voila, you've done machine learning. It can be a bit more complex than that, of course, otherwise we wouldn't be here. And then there's a subset of machine learning known as deep learning, and that's where you take layers of what are called neural networks, computer programs that try to mimic how the brain makes decisions. And if you stack lots and lots and lots and lots of these neurons together, you can make it so deep and complex that we call it deep learning. And that's typically what most algorithms that you'll start to see nowadays, including ChatGPT, are. So that's a textbook answer of what we think AI, machine learning, and deep learning is. We said it was an icebreaker. Sweet. So yeah, as we said, we'll give you a quick overview of what we've done at the Centre for eResearch at the University of Auckland and at NSE. And so if you're not fed up of hearing me talk, that's great. If you are, doesn't matter. So at the University of Auckland, we actually gained a bit of funding to start teaching machine learning and deep learning, precisely introductions to this to try and upskill our researchers. So in 2023, we gave some carpentry-style workshops using some modified carpentries material. We delivered it to university researchers in 2 phases. We had a first workshop early in the year, which was our first ever one giving it, and then a second, slightly more refined one in September. And the way it worked is we had about a 4-hour afternoon over the course of 4 or 5 days. The first time we gave this, we tried to go from introduction to Python all the way through to an introduction to deep learning so that you could onboard anyone into the lovely world of AI. In hindsight, that's a big stretch. And so we learned that the hard way, both as instructors and as pupils. So when it came around to the second workshop, we actually chose to drop the introduction to Python and made Python a requirement for coming to the workshop. We actually then expanded the introduction to machine learning to cover a few more of the fundamentals that we thought was missing. And then once again, we gave the introduction to machine learning and then an introduction to deep learning. What did we do precisely for these 2 topics? So for machine learning, or ML, deep learning, DL, we used scikit-learn, which is a nice Python package to give you an introduction to lots and lots of techniques in machine learning. We covered supervised methods, so regression and classification. We taught ensemble methods, which just starts to bleed you into deep learning a little bit more. And we gave unsupervised methods, such as clustering and dimensionality reduction. So we gave a broad flavor overview of the introduction to machine learning. Likewise, with the introduction to deep learning, we went over a couple of examples of how to use CNNs, convolutional neural networks, for the use cases of classification and prediction. And we used Keras because it's an easy-ish tool compared to teach. So that was what we did at the Centre for eResearch. Maxine?
Okay, so at NSE we did also a couple of machine learning workshops. So our audience in our case was all of Aotearoa New Zealand researcher, and we started to do that a couple of years ago, and we have 2 main formats. The first one we call ML 101. It's a 6-hour long workshop that nowadays we split over 2 mornings to make it a bit easier. And it's really introductory material to machine learning, very similar to what Mike already said. We don't cover unsupervised learning, sadly, no time for that. So far we ran 7 of these workshops in a mixture of in-person and online. This is a picture of the first one in person. It was a bit stressful. network was not working. So, and in total we had about 127 attendees ranging from 10 to 32. And the second type of workshop we had is the ML 102. It's a little bit shorter, and this one is Introduction to Deep Learning, focusing only on computer vision, so convolutional neural networks, or CNNs. And this one we started it a bit more recently in 2022. And so far we delivered 3 online workshops with 47 attendees in total. And I'm very happy to announce that we'll have another ML 101 workshop in March, and we have an expression of interest which has been published on the NESI website. Anyone is welcome to register to this one. In terms of how do we deliver this, what is the content and how do we deliver this? ML 101 is based also on scikit-learn, and it's no surprise because it's a very wonderful Python package. Well structured, I love it. And there is also a wonderful tutorial that was made by Jake van der Plas, who is a data scientist at Google, and it was with Creative Commons license, so we shamelessly reused that. It was really good, and it's based on Jupyter notebooks. And for ML 102, we switched to using the TensorFlow tutorials, which actually were very good in terms of training material, and we added a few more things here or there, and they're also Jupyter notebooks based. And to deliver these workshops, we were using either the Jupyter on NESI platform, so it's a Jupyter Hub platform, or the new flexible training platform that NESI is developing, which relies on open and demand. And if you want to know more about this one, I really invite you to go to June and Kahu's talk tomorrow. Some time ago, we had a little chat between CER and NESI, and we thought about, hey, we did this, and what did we learn from our own experience and struggle? And for people who may have been to eResearch Australasia, we actually gave a whole talk about this. So this is the sort of a super condensed version in 2 minutes. But here are some key points if you want to do ML trainings. Some of these points are very generic. But have an expression of interest for your registration because it's hype. A lot of people will want to register. And so you may want to select the audience based on do they know how to code in Python, which will be a prerequisite, for example. And some people will just tick, yes, I want to attend. It's like, actually, you know, maybe you need to do this other course before. Make it online. You'll have you will recruit a larger crowd of people and some people who may not be able to attend in person. Use an online compute platform. This is something where we depart from sort of the carpentry style of approach where you would want people to install things on their machine. But again, this is not anymore introductory to Python, so you may expect people to already know how to install Python on their machine. So you want to skip this stressful first hour when you try to make things work on every laptop in the room. You don't need a fancy GPU. That may come as a surprise, but you can start learning how to do machine learning and deep learning without a GPU. Later, you may want one, but for learning, you don't. Reuse and adapt existing material. As we both mentioned, there's really cool stuff out there. Just a general thing, but because if it's online, try to stick to shorter session. I mean, it's a lot of cognitive load, and people can get some Zoom fatigue. And the final thing is a very technical point, but MLP means multi-layer perceptron. That's one kind of neural networks. And when people want to teach introduction to machine learning, they say like, oh yes, I'll go with MLP. Like, no, actually there is another very simple and generic thing, which is random forest. And you may want to learn this one first. And once you're comfortable with this one, you go to the deep learning section and you learn about MLP. If we want, we can talk more about this point after. On that note, over to you.
Thanks, Maxime. I can confirm that random forests are awesome. I've used them in my own research, and they're really, really good, really, really fun. So part of this BOF, we'd like to kind of get a sense of what researchers need in New Zealand in terms of like capabilities to perform machine learning, but also in terms of training. And so we've devised a survey, which we'd like everyone to take part in groups. So you'll notice on each of the tables, there is a bird that you can see in Wellington, although I've never seen a little blue penguin in New Zealand, let alone Wellington. Yeah, if you follow the link here, you'll be able to get to the survey document, and then somewhere in the document you'll be able to find the section that's associated with each of the birds or your group on your table. And we'd like you to like work through 12 questions to kind of get a sense of like what do you need in terms of like learning or how to perform machine learning, but then also what requirements would you need in terms of developing like code or developing models and whatnot. So we'll spend the next 30 minutes on doing this, and then the aim will be to come back at the end and then report back so we can kind of get a sense of where we are, where the machine learning landscape is in terms of eResearch New Zealand at the moment.
It's currently just after 20 past 4. We'll give you like 5 minutes to put some more in. I can see most tables have put a pretty good dent in that monstrous survey that we've just given you all. And there's been quite a bit of discussion. What I will point out is if you scroll to the very bottom of that Google Doc, there's a little section we've put entitled emails. We don't have time to listen to everyone and all of those answers because we gave you 10 billion questions. But what we would like to do is get in touch with you afterwards, and we'll go away, collate all of this information that you've given us, and then feed it back to you all for anyone who's interested, and put your email there. And then we'll probably go a little bit further and start maybe trying to set up some kind of discussion on how we can start bringing upskilling of machine learning and AI into New Zealand a little bit more, and probably advertising Nessie's lovely every researcher teaching. Laura.
Mike, could you please open the browser and tell everybody about RESBAS?
About ResBaz. I can. I need a laptop first. So yeah, just to remind that, we've got a few minutes. No one wants to be late to the next thing. So fill out whatever you want of the next bits. And then if you're interested in hearing from everyone, don't forget to scroll right to the bottom, put your email there, and we'll be in touch with this lovely information. And we'll formally close in 5 minutes or so with another clapping and talking. Okay. No, I started my own one. Awesome. Thank you, everyone, for participating. It's been great to actually hear the buzz in this room for the past hour or so. With that, we'll wrap up this session, but what we would like to do is point out this lovely thing up here called ResBaz. I know we've got a few CRIs that maybe haven't been looped into this before. ResBaz is a week-long online taster workshop for all kinds of software and tech stacks and everything. It's now for all of Aotearoa and all the researchers there. It's free to join. If you put your email at the bottom of the list before you go, we'll also let you know about this. I think last year, how many people signed up, Laura?
We had 5,000 registrations.
If you help us pump those numbers, then we'll all get very happy, and hopefully you'll learn something as well. So that's beyond machine learning and across the entire eResearch space and tech space. Check it out. And with that, I'd like to say a big thank you to all of the other co-presenters and all of you guys. Kia ora. Thank you.
All right, awesome. I'll let everyone get seated, and our next speaker is Paul Gunn from REANNZ, and how we're using eduroam to reduce digital inequality.
All right then, as introduced, I'm Paul Gunn. I'm going to talk through some of the work we've been doing with eduroam to help reduce digital inequality. I'm going to start with talking a bit about how we're using eduroam in New Zealand at the moment, and then I'm going to talk through some of the challenges we're trying to deal with and some of the work we're doing to resolve the laptop situation. So, first up, eduroam in New Zealand. It's present in universities, the Crown Research Institutes, Tipu Kenga. That's a lot of R's in this name here. There's R for REANNZ for the researchers here. So this one is not really covering the second piece, but we've got eduroam rolled out through all of these institutions and they're using it. It is valuable, it's used. One of the things we heard during 2020 is the students from SIT would come and park up around the library at night to get access to internet using the eduroam provided from the library on the campus there, because there wasn't internet available when they were all sent home during lockdown. So there was groups of people just going to the library and just parking up, all in their bubbles of one, all night, working around the library. So there's a real use for this out there. Also, shout out to University of Waikato and University of Otago, who have gone to rolling out eduroam as their default, aren't they? They've said they will, so that's all good. No pressure. Where is eduroam in New Zealand? Let's look at this wonderful map up here. You can see that we have the southernmost eduroam access point in the world on Stewart Island. We also probably have the easternmost and the westernmost access point in the world. If it wasn't for the Norwegians, I'd probably collect the whole set, but there you go. I thought that was just like, well, that's kind of nice to know. Possibly the Fijians have actually got it because they sit closer to the date line than I do, but that's all good. But there's more we can do here. This is just covering the environment as it is for the researchers. So what can we do for education for secondary? What can we do to resolve issues around digital inequality? This is stuff you probably know or seen around here. It's all kind of These are real challenges we've got to work with. During 2020, as a lot of things became very clear, Ministry of Education approached REANNZ to talk to us about using the tools we had available to help work with issues in digital inequality. eduroam was the one that seemed the best match for the tools we had already where we could help in this one here, because it's global, it's secure, it's safe. So let's go. What can we do about this here? We started working on a program to try and roll out eduroam, created a space of network of connected spaces, and that's what we're trying to do now. Is we've got eduroam in the research in universities, but where can we take eduroam to places where other people can use it? How can we resolve issues of students not having good study spaces at home, not having spaces where they feel safe, spaces where there's good connectivity, where they've got connected devices? These are not all problems REANNZ can solve, but it fits into an ecology. So we're providing the back end for it with eduroam. Other parties will come to play in this one here. Why is eduroam the right one for this one here? It's secure. You can set it up so it uses certificates on the devices. So rather than usernames, passwords, you just roll out a certificate to it. You can have it check against certificates on the home servers so it's resistant to man-in-the-middle attacks. You can get it deployed by trusted partners like schools. They can deploy it on school-owned devices, or they can deploy it on the school. Thank you. Also, important for dealing with issues of digital inequality here, by having it installed by a trusted partner, you avoid friction or exclusion over concerns about cost, or concerns about installations, or what permissions are required. You've got a platform that just works and it's consistent and set up securely across the whole environment. Is it a tool that other people are using in education, in secondary education here? We're following a model that's used overseas. Another shout out here to Utah Education Network. All 42 of the districts in Utah school districts all deploy eduroam. So we're just following a model that other people are using. Researchers in North Carolina, they're actually deploying eduroam at home. So students are provided with eduroam equipped laptops, Chromebooks, and they've got it at work, or got it at school, and they can take it home as well. So there is research at the moment happening to see how much difference it makes. It's probably a 2-year study, so it'll be a wee while before the results come out back on that one. But it is a study seeing how valuable. Have you sold me a pup, Dave?
I was going to say, blame the laptop.
That guy. So what are we doing now? We're trying to roll out eduroam to schools in New Zealand, targeting the secondary schools. There's 800 secondary schools in the country. That's about 500,000 students. So Ministry of Education is dealing with that piece there. They have the relationships. They know their schools. They know their people. So what we're doing is we're doing the other side of it. Ministry of Education, they look like they're going to, as I say, the goal is 500 schools by the middle of the year. The first one probably is going to be Te Kura, the correspondence school. They've got 25,000 students enrolled a year, which makes them the largest school in the country. And they've got students all up and down the country there. People coming from rural areas, people who don't fit into standard educational platforms here. Up and down the country, that's a bit of a challenge. But that's where we've put in our work to actually roll out eduroam to all the APNK libraries around the country. There's about 160 APNK libraries in the country. I'm not being very clear on the number because libraries move around more than you'd think. There's currently 2 in transit, which is a frightening thought, a library moving across the city. But anyway, so there's about 160, it goes up and down a bit, but that's, Dave, 160 libraries up and down the country, which is a lot of locations. You've got to be, and there are a lot of them are really small libraries in rural areas there. Those are areas that are hard to reach, but there they are. We rolled out a proof of concept in Southland and Otago of Dunedin late last year. We picked those areas just because we knew there was a large proportion of tertiary students there. So we were able to actually see how this was going to roll out to a large area, what if there were any issues, what was going to happen. So that's what our proof of concept area looks like at the moment. There's about 15 sites on that map there, spread nicely across Southland, not in Gore, it's a different council, in Dunedin, but not Central Otago, that one there. So that rolled out in August, amazingly quick. As soon as we got it up, within half an hour of it going live, there was a Canadian academic trying to connect in Tianao. The first people to connect to the Stewart Island one, that was 4 students from, well, 4 devices from the University of Nantes in France. Well, the first people were going, yep, eduroam, that just works. And this is what we're going to have live by Friday next week. 160 sites. That's the Lord of Thunder. 160 sites. They starts rolling out on Sunday night. So that'll be good fun for the people who like doing late evening changes. Yes, Sunday night. It's 30 a night, so that's fine. So it's going to walk its way up the country. I think we're going to get Canterbury first, then North Island, then chonk, chonk, chonk. So it'll be very pleasing. And this is some of the information we've got from this study, how many people are actually using this. And this is really valuable because this libraries are kind of, you put them there and learning happens, but it's kind of sometimes hard to really say, where's the value? This is very clear. You can see who's visiting the libraries. You can see who is using the network. You can see who's going in there. You can see SIT and Otago Polytechnic, because they're really strong at providing eduroam. Some University of Otago is a bit further down the list there. But this is the people going into this here. You can see there's a lot of overseas visitors as well, because the south of the South Island is a very beautiful part of the world, well worth visiting. Institutions overseas, 403 institutions overseas. So you can see, this is the kind of information you can see that allows you to work out who's collaborating, who's visiting. They're visiting a library in this case, but this could be a university or a CRI. This information is available for universities and CRIs if they want to know how the collaboration's happening here. We've got 39 countries. It's almost always Australia, Germany, Australia, United States, United Kingdom, with Germany about 4th. It's very clear from looking at some of these results. You can see the exchanges happening. University of Auckland has a summer course for students from a university in San Diego who just show up like a big blip on the graph because there's an exchange every year during their winter break. But this is working well at the moment. We've still got a little bit more work to know on this, and this is rolled out, and that's 160 sites. The next step for doing this is trying to work out more places where we can bring eduroam to reduce some of these inequality issues. Whakatane, that's our next location where we're probably going to be aiming for a proof of concept. Whakatane is a really good one for us here because we've got Toi Ohomai, so we've got one of the ITPs present, Tipukenga. We have Te Whare Wānanga o Awanuiarangi, who also use eduroam there. We have Trident High School, who are interested in talking to us about rolling out eduroam as being one of the first players there. We're going to have the library there, and a new one over here, Te Hokafutu Marae, working with us to roll out eduroam on their marae. As part of a previous work together with TPK and Crown Infrastructure Partners, it was a Marae Connect program to bring Wi-Fi to each of the 600, 700 marae in the country. There's about 700. Last time I checked, there's about 650 of them are connected. So we are going to work with iwi and approach them saying, do you want eduroam on your site? Is this of value to you? So that's the next stage at the moment. We're just starting on that journey, is reaching out to iwi to say, is this another thing that's valuable to you? And we can point to the success that we've had with the APNK libraries and say, is this what you want to do? And this is kind of just for giggle value at the end here. This is the conference. This is when I looked at the results this morning. I got eduroam deployed here about 2 weeks ago. and I've just left it running because it was like once you stand it up, you might also just leave it running. No point turning it off and turning it on again. So this was results before lunch this morning. You can see a number of people who visited us. Quite a few of them are from the conference, but there's a lot of people who came in beforehand here. University of Otago, good strong showing there. REANNZ doing quite well as well. Overseas visitors as well. It's almost like this is an international hotel, so we get a lot of people coming in through. And again, Australia, United States, United Kingdom is the top ones there, with Germany almost always in fourth. Are there any questions?
REANNZ keeps finishing too quick.
I tried to put more slides in, but I was told to take them out. You there, sir? Oh, we would love to reach out to them. It's one of those other things because it is a teaching environment. I think they were on about that slide back here. I may have deleted that. Here we go. These are the areas we're interested in working at. Today I've focused on the ones that are particularly relevant to areas of digital inequality because that's the libraries, that's Mirai. But eduroam is also, the more of it is, the more valuable it is. It's very much an ideal example of a network effect there. Yes, we would like to get in more teaching hospitals, so we have eduroam deployed around the Southern District Health Board, whatever it's called at the moment, around there, which is, we can see is clearly used by University of Otago, SIT and Otago Polytech students. So it's there, and that means you can just walk off campus and still be on campus. So it's an area we would like to work on. It's not the focus of today, just like stadiums and transport hubs. We'd also like to get into airports because that is actually sort of standard practice in a lot of Europe. Norway, it's in all of the Norwegian airports. Queensland universities have kind of pushed for it to be in all of the airports in Queensland. So, 5 minutes, it's cool. So it's present in Queensland airports, Darwin Airport apparently, from local reports there, South African airports, they've got it as well, so it's just very easy to work through. SITs particularly wanted me to put it in Christchurch Airport because they have to transit through Christchurch Airport every single time. So that makes a lot of sense for them. But yes, we'd like to get into those places as well because then you just get a place where you can just move from campus to travel and just keep studying, keep working, keep collaborating anywhere along the path.
I think it's important to also remind everyone that there's a service, it's mostly free for members especially, so take advantage of it. Most of the people that are attending here are members of REANNZ or work with REANNZ somehow, but if there is a place of digital inequality that you know of, email us. That's exactly what we're trying to do. We're trying to achieve that, filling in the gaps. And we've been working on it for the past 2 years now. And we don't want to have to keep trying to find places. You're more than welcome to come.
Yeah.
And we can send out the boxes as well, from the Ministry of Education, instead of changing anything up in the system, if it's just easier that way, to just enter them in a box.
Yep, or Mirai that are interested as well. I understand there's a lot of Mirai in Northland that work with University of Auckland.
So from University of Auckland, how do you deal with peak demand? Because come around peak, our wireless historically has struggled. You can see students complaining left, right, and center when you go to Starbucks or whatnot type thing. And I've occasionally found that jumping on the eduroam side of things makes life easier for myself. But do you have the same type of?
Well, that's the thing. eduroam sits over. eduroam will not fix a bad Wi-Fi installation.
How am I to get connected to eduroam better than I can on my own network?
That's a fascinating question, and I would not dare to speculate in a public forum.
University of Auckland engagement manager, if you chat to him afterwards.
Cool. Oh,
We are trying to make universities use eduroam. They've got it. We want you guys to push it out to everyone, and to the students especially. It makes your life easier, and in reality, internationally, it puts New Zealand on the map. So.
cool. Oh, if that, thank you very much for your attention.
Thank you so much, Paul. All right, next up, we've got Chris Chamberlain and Christopher DiCaprio for taking the lid off National Seismic Hazard Model Technical Delivery and New Zealand Research Project in the Age of Cloud Computing.
Okay, great, thank you. I'm Chris DiCaprio, and this is Chris Chamberlain. Luckily, with the same name, but physically it's easy to tell the difference between the two of us. So we're from GNS Science, and we're going to talk a little bit about the sort of IT, technical software, computational side of the National Seismic Hazard Model program. So the brief outline. First, I'm going to introduce the science of the NSHM, just so you know, kind of have a sense of what we're talking about and why we care, why we're doing it. And then we'll give you an idea of kind of what our team looks like, how we ordered our work, and sort of what were our guiding tenets. And then I've got a story of sort of how we actually calculated the final part of the model, called a story of fear and scaling. And then we'll close out with a sort of discussion of how we use cloud architecture and how we find all the millions of different scientific artifacts that we generate over the course of the research program. So what is the National Seismic Hazard Model? It's what's called a probabilistic seismic hazard assessment, and it produces a forecast of shaking due to earthquakes all over New Zealand. So that's the seismic hazard, and that's used to inform building design and regulations, so new building code. It's used by risk analysts from insurance and reinsurance companies to assess their risk exposure to earthquakes, and used by communities for planning and risk management. And in 2022, we released a new revision of the NSHM, and this is sort of what's plotted here is basically the fundamental product of the model, which is called a hazard curve. So on the x-axis, you've got ground shaking, in this case in terms of acceleration, and on the y-axis, that's the probability of experiencing that shaking. So this is in Wellington in particular, I think, sort of how much shaking you might expect in Wellington. And what's important to note is that it's not a single model, but it's actually thousands of models, sort of thousands of different possible futures for what shaking we might expect. And then that's all sort of boiled down into aggregate statistics. So usually we're working with the weighted mean of all those various models, but we also include sort of confidence bounds to give a sense of how certain or uncertain we are about our forecast. And then we might take a particular spot on that hazard curve. It corresponds to a particular probability, say like a 2% probability in the next 50 years, how much shaking we might expect, and produce maps like this one. There's a lot of words on here that I'm not going to read, and you shouldn't read either, but the point is the highlighted one, that the team is made up of more than 50 scientists and specialists from all over the world, a lot of us in New Zealand, but a lot of international collaboration as well. And that was a big part of kind of the challenge of our group, of sort of our little working group within the project, was sort of how do we make sure that we can share all the results, make them easily discoverable, how do we kind of facilitate experimentation and discovery. So Chris and I sort of represent a very small group within the project called the Computational Working Group. We have a small team of developers that sort of shrinks and grows a little bit. At the moment, there's just 4 of us, sort of so I'll give you a sense of who we are. And I think this is sort of interesting because Chris and I come from very different sides of the sort of scientific and IT world, and it's sort of an interesting collaboration. So I have a background in geophysics and some experience in scientific computation, like inverse methods and finite element methods, but no experience in cloud computing, no formal or informal training in sort of software architecture. So I've sort of came into the team to provide scientific guidance, but have sort of become I don't know, researcher, DevOps, sort of everything, because we're such a small team. So I'll let Chris introduce himself.
Didn't we decide it was DevOps scientist?
Something like that.
Yeah. So this is my first real immersion in the world of science, and wow, what a ride! Pretty cool. The other people on the team, I mean, my background's up there, so I don't need to go through that. We had a year of a specialist Java developer from within GNS Science. We seconded Oakley. You'll see some names whizzing around later, so it's worth saying. And then Chenye and Ben were junior front-end developers that we brought into the project early, trained, doing science sort of oriented for the team front ends. And eventually they built, later and under some pressure, the public-facing website, yeah. So I'm going to flip to a little movie and hope this works.
Oh, you're going to have to move it to the other screen, I think.
What do I have to do?
It's on the other
Magic.
screen. Yeah. See if we can get this to work.
Thank you.
How many? There. Give it a go.
Yep. Now I can't see that.
Yeah, you'll have to turn it.
Do I have to go like that?
Yeah.
Wow. Bear with me, folks. So what we're about to see is something that's to keep me on track about the development, the organismic development of our code base across nearly 30 repositories. And what you'll see are the developers at work, and the developers include us. Is it working?
There we go.
Yeah. No audio. I'm the audio. Yeah. So that's me. These are scientists. We tried to bring scientists in to work on the code alongside us as early as possible. Just have to keep an eye on this. And we're in 2021. As you can see, some of the tenets were coming through early, like we wanted our code to run anywhere. Have I got past? Yeah. And we'll talk a bit more about that. Grand inversion is the first part of the modelling that really caused us some grief. And now at about this time, late 2021, and we're delivering the model in mid-2022, our internal GNS HPC cluster got really popular, and we suddenly didn't have access to it for weeks. So we quickly, having done some work to prepare for this, were able to migrate these compute-intensive tasks into AWS, thank goodness. And doing sensitivity tests, more sensitivity tests, more code. Stop there. Briefly, we ran into another glitch, approximately April, May. We call it the Tale of Terror. Chris is going to give you more of a detail of that. Time is getting tight. But the code continues to be built. We publish the model, crazily, on time, and that included the public-facing website. There's review with the working groups, the engineering community, who are figuring out how to use this for the new building codes. And now in the last 6 months to a year, we're focusing really on polishing what we've done, publishing it, making it easy for outside parties, and we're talking insurers, research students, anyone who wants to reproduce what we've done. So that's underpinned everything we're doing, and that's where we are today. Cool.
All right.
And Chris is going to tell you now,
2 slides.
but you're going to do the manipulation.
Yeah.
Yeah, cool.
Oh, this is very hard.
we go. All right, cool. Oh, no, you have one more slide.
Oh,
Sorry.
this is highly rehearsed. A little bit of the guiding tenets, things that we set out with in mind before we kicked into all of that work. So one of the first things we established was everything we do is we should make it open source. So there's already the GNS Science organisation and GitHub. All of our code is available there. Then, not knowing quite how much artifacts and experimental inputs and outputs there would be, but knowing it was just going to grow, we thought, well, look, we've got to be able to reproduce this work. So a lot of it, our thinking was about how to capture all the stuff. And of course, we have to do it within a budget, so we're looking at ways to make that manageable, not just for the duration of the project when all the scientists are going crazy and running experiments, but also afterwards when we're running this public website for the next decade or whatever, until the next model's produced. And I think quite importantly, and you saw the need for it right there in the middle of things, we basically had to switch off an internal HPC at GNS to running on the cloud. So having put a bit of thought into that up front, being able to run the same compute work on a workstation, push it in HPC or run it in cloud was really a lifesaver. And it's not so hard if you think about it in advance. Okay, Chris?
Now you got the video again. Let's skip it. Okay, so this is a quick story about the calculation of the actual hazard curves. So the sort of final part, we've got all the different pieces of the model, and now we've got to put them together to actually produce the hazard curves that we care about. So I mentioned in one of my first slides that this isn't a single model, but it's many thousands of models. Once you do all the different combinations of what are called the logic trees, you end up with nearly 1 million different models. And we were using, and still do use, a piece of software called OpenQuake that's produced by a group called GEM, the Global Earthquake Model in Italy. And that's the software that actually does the hazard curve computation. So it gets the distance from a particular site to all the earthquakes and runs them through ground motion models and actually produces a hazard curve. And we started experimenting with OpenQuake and giving it a model just a fraction of the size of what we wanted to run. It didn't work at all. It wouldn't even get past its initial phase of enumerating the logic tree. And so we've got about month and a half or so, maybe 2 months before we actually have to deliver the model. We're hitting these time and memory bounds of the software we're using, and we started talking to the developers at GEM and asking, are we doing something wrong? Do we have to totally change our approach? And what we eventually came up with was a strategy to break the model, to decompose the model into parts and do the calculation in 2 stages. So we realized that due to sort of the structure of the model, there aren't 1 million independent parts of the model. There are really about 1,000 independent parts. And we can pre-calculate those independent components on modest hardware. So we started using AWS EC2 to calculate the independent components and store that sort of intermediate result in a cloud database using DynamoDB. And then in stage 2, we can combine all the independent components of the model to form the sort of nearly 1 million realizations. That's the nearly 1 million possible futures that are included to quantify the uncertainty. And then calculate the aggregate statistics, which is what are actually used. So we can calculate the weighted mean and the weighted fractiles from that. And then we store those results in another AWS DynamoDB database. So the diagram here is really just sort of we published a paper on this in SRL recently, and the diagram is sort of showing the computational workflow. So the entire calculation is sort of controlled by what's called the logic tree. That's the definition of the structure of the model. And then we've got some libraries that break that into parts and launch OpenQuake jobs in the cloud. and results are stored in DynamoDB, and then we can come back later and sort of combine them and calculate aggregate statistics. So we're able to throw just a lot of compute jobs at this at once. So we're running hundreds of concurrent jobs in the cloud because we've got there are 900 independent parts of the model, but we have to sort of do that for multiple dimensions, all sorts of different site characteristics, different shaking frequencies. So we have to redo this calculation several times, and so we just throw a lot of compute nodes at it, and it takes, depending on each job takes 1 hour to 24 hours, so it's not too bad. And then the recombination is actually quite a bit faster. We can do it in the cloud, and we have when we're kind of needing to do a lot of it, but often I just do it on a local workstation. 40 cores, it takes about an hour to reconstitute the model and calculate aggregate statistics. So this is what's called an embarrassingly parallel problem. Once you've got the individual hazard curves computed by OpenQuake, you've got the individual parts. Every point on that hazard curve and every dimension of the model parameterization, totally independent. There's no message passing required. You just parallelize to your heart's content. It scales as big as you want. So it's quite a nice problem to have. And it sort of gives us some advantages as well. Doing the calculation in 2 parts gives us the ability to sort of do some experimentation with the model. We can do some sensitivity testing that you wouldn't be able to do if you had to rerun the whole thing every time. And Chris is going to talk a little bit more about the sort of architecture of the whole system.
Thanks, Chris. There's a lot of overlap or similarity. This really just explodes and adds a little bit more to the previous diagram. So the key layers are the management of the process, and REANNZ is a sort of our automation launching code base. Down here we have the common libraries that we ended up breaking out that do particular things, and we want to make those available to other researchers just as Python libraries. So they don't have any, they have as few dependencies as possible, and they're as focused as possible. Then we expand, of course we've got the same good old Amazon classic services, so they're identical to the previous diagram. This blows up a little bit the detail of the API, but it just basically is showing that the API is sort of decomposed into functionally related areas that have a lot in common with what's going on at the library level. But these are running as serverless functions in which is basically pay for each invocation each time a user hits something on a website that queries of the API. That's one function execution, or in fact 2 if you've got a gateway like we have there. That's the first one, and then whichever one we go to, it's the second. So over here on the right is one of the front ends, and that's the public website called Korora, after this empty table down here. So people using the NSHM as an end user through the website, basically calling down into this fabric that we're seeing here. This slide just summarises the things we do with cloud types of technology, and AWS are a big chunk of it. The reason, I mean, it's really important that we had this thinking, I think, that we could run up any of our core jobs or tasks, experiments, call them what you will, in whatever environment we could A, get hold of, or B, was most cost-effective or suitable for the job at hand. In the end, we ran most of the heavy-duty stuff in the Amazon cloud. Experiments at scale using serverless. This diagram here shows the, there's no dollars there, but that's the compute cost over a year of building the model. So over the most recent year, so it's actually not showing the full cost. There's a 6 months before that. But as you can see, it's really spiky. There are months where there's not a lot of compute activity at all, and then there are other months where it's heavy duty. So when you've got a very spiky load, you want to make sure that you're not paying for stuff that you're not using. So that's where pay as you use type solutions are great. GitHub, I think Andrew mentioned Git a lot in his talk earlier, and it's just fundamental sort of technology that keeps the team well oiled. One of the other challenges you have when you've built up to 18 months of experiment is there's a lot of artifacts that may or may not be needed again, and we're building making use of the Elasticsearch, or OpenSearch I think it's called now, engines basically to index all of the inputs and outputs and key artifacts that are produced through this whole process so that scientists and we can lay our hands on stuff. And I think also so we can clean up after ourselves. Some of the stuff will actually be able to be disposed of eventually. So where is all the stuff? Somewhere in there. Okay, yours, Chris, right. Closing out.
I got the last slide. Yes, so that's where we are now. We delivered the model in 2022 with some refinements to the mid-2022 with some refinements to the user front end kind of throughout the year, and then we've been publishing papers and cleaning up. We've got a lot of technical debt from the sort of breakneck speed we were running at in 21 and 22. So now, what are our next steps? So the big goal now is improving the usability of our libraries. Other groups, research groups, would like to reproduce our results. Engineering consulting firms and risk analysts would like to be able to modify and tinker with the model, and they currently can't do that because it's all kind of built on custom code. And you could sort of see our IT stack is not something that we can just coach people through standing up quite easily. So we're trying to abstract all of that so that it's and document it so it's easier to use by third parties. And we continue to work with the global earthquake model, the developers of OpenQuake, to make sure that everything we do is compatible with any future developments. And then kind of a stretch goal at the moment is hazard on demand. Everything that's served through the public website is pre-computed, and we would like to be able to sort of provide on demand for specific sites and site conditions that's not available just yet. Any questions?
Have you given any thoughts to containerization or even pushing things up to PyPy or Conda? Because it seems like something that can easily be put into an environment or a container.
Well, what allowed us to do the AWS batch migration so quickly was we made sure right from the start that even though we were doing stuff on HPC, we were also building and testing Docker containers. So that meant within a week we basically were able to get the stuff that had been running on the cluster running up there.
Questions? We've got time.
Yeah.
1 second. Just because we're recording.
Sure. Happy.
So you guys have actually achieved a huge amount of stuff. How big was your team in entirety that was just developing the software section of that?
Well, we did two main, the team size that did all that stuff was Chris and I, a Java developer, Oakley, and two front-end developers who we sort of, I trained and set up the stack, and we basically just got them going early. And of course there were scientists also that were doing some contribution, but Chris and I wrangled the bulk of the code, particularly all the automation, the development of, I did the Docker container stuff, for example. Chris really got his hands dirty with OpenQuake and figuring out whether it was feasible to do things, break apart OpenQuake and get the aggregation separate from the hazard curve realization. Thank goodness that was possible. Yeah. So that was at 5. We were working pretty hard, but it's exciting.
One more question.
Great work, guys. Serving up the pre-calculated results versus hazard on demand are two slightly different ball games. How much work do you see is going to be required for hazard on demand?
A lot.
We've decided to, I think, a lot of the stuff Chris mentioned, we're doing some technical debt cleanup, better documentation, more tested coverage. We have tried to test cover as much as possible. That did help a lot, but still it needs to be in better shape to let it out into the wild. But all that work's going to benefit us and is helping us actually, break down the key components and focus on the things that would underpin that hazard on demand. It's pretty doable. I don't think we'll get there by July, which is where we're currently have funding for, but
I think a lot of the sort of making it accessible to third parties is streamlining the workflow. It sort of requires a lot of hands-on maintenance at the moment, and if you can make that workflow as automatic as possible, then that facilitates hazard on demand somewhere down the road.
For an on-demand site. Yeah. For an on-demand site, how long will it take to generate a hazard curve, or do you reckon?
If we do the full model, so there are paths forward where we come up with a reduced number of realizations that can reproduce the uncertainty bound estimates that we have. But if we were to do the full model, if you've got the luxury of money of throwing enough compute instances at it, it's a few minutes if you can streamline the workflow.
That's for one.
That's for one site.
One site with one site condition. We've had to do a grid across the whole country, and it's a 10-kilometre grid at the moment. In places like Wellington, for instance, we've yet to, but we may well do a smaller grid there in the future. And of course, if you've got one site, the site condition, which is one of the other dimensions that scales the whole thing up. So, yeah.
Any more questions? I actually not a researcher or technical, and I absolutely loved that. It was really interesting, and it was so interesting how you guys used AWS to actually try to make it go a little bit faster, and of course cost. So thank you so much. I will end this session now by just reminding you guys that conference dinner is tonight. There's lots of yummy food. I think I talked it up too much now. Hope I didn't get anyone's hopes up, but it will be nice. You guys are more than welcome to, really kind of go along whenever you like. It does start at 6 p.m. and you will need these to enter. So that is really kind of why I brought this up. I was like, there was a reason. I was told that for entry, you will need to show your cards. So bring them along. And I hope you've had an amazing first day, and we'll see you guys tomorrow morning. Well, tonight and then tomorrow morning. Thank you.